Question 14. The figure below represents a triangular prism, and of course the cross-sectional area of what we have here is in form of a triangle. And the faces A, B, C, D, A, D, E, F, and C, B, F, E are rectangles as shown in the diagram. You have been told that AB is 8 centimeters, BC is 14 centimeters, BF is 7 centimeters, and AF is 7 centimeters. So you've been asked to calculate the angle between faces BCEF and ABCD. And of course, this comes from a topic called three-dimensional. And of course, you've been told to get the angle between those two different planes. There's a possibility that a question can ask you to get the angle between two lines, the angle between a line and a plane, and the angle between two planes. So for such a case here, we are expected to get the angle formed between planes BCEF. That is BCEF. This top part that is slanting. It actually looks like a roof actually. And ABCD, ABCD. So what we are supposed to actually do is to first be able to capture or be able to come up with what we call a projection. A line that comes from the top of what we have as our blend BCEF, and a line that gets drawn to serve as a projection to the base of what we've been given as ABCD. So I'm going to draw a line from this end to this end and be able to draw another line from this end to this end. And this can be the center of this projection. Then I can draw a line from this end to this end. Look at that. So they are looking for this angle. So between this plane and the base. So between this line and this. So we can draw this and be able to come up with that calculation. Okay. So we have been told that BF is 7, then that means this is also 7. I can be able to actually take this as X and this as Y. So we have X, then Y. Of course, the distance XY should be equal to the distance BF. So this must be 7 centimeters. And we can pick this to be O. So I have X and then O. So I can put here O. I know from A to B is 8. So that seemingly can actually be able to get halved, so that the distance from this point to this point can also be able to get obtained. So I have this length as 4, because the whole length from this point to this point is 8. So if halved, then that means XO is going to be 4. And they're looking for this angle theta here. We are going to use what we call trigonometric identities for us to get the angle formed at that point that can represent the angle between planes BCEF and ABCD, the one at the base. So I have this adjacent and the hypotenuse. I can use cos, so I'll be able to say cos theta is equal to adjacent over hypotenuse. And you shall say now cos theta is equal to, okay, our adjacent to that theta is theta. Adjacent. This is our adjacent. This is our hypotenuse, the longest length, and this becomes now opposite. So our adjacent is 4 and our hypotenuse is 7. Right? And we will proceed and have this. Let me just push this to this end first. So we're going to have cos theta being equal to the adjacent 4 over the hypotenuse 7. So the cos inverse of that can give us the theta. So shift cos of 4 over 7 gives us 55.15. So our angle is 55.15 degrees to 2 decimal places. That becomes our angle that is able to get formed between the planes B, C, E, F, and A, B, C, D.